As this flowchart shows, nested loops are structured in a way that a complete loop is included inside another one. Each cycle of the outer loop is done after completing all cycles of the inner loop. That means that the flow control starts with the first cycle of the outer loop, and when it reaches the inner loop, it carries out its all cycles according to its looping condition. When the inner loop ends completely, the control exits to complete the first cycle of the outer loop. Similar to the structure of compound conditions, the nested loops and their blocks are defined in the code according to their indentations. The inner loops are the most indented to the right. You will see this very clearly in the next example. So we have the outer loop is I, which ranges from 1 to 11. The inner loop goes from 1 to 11, and the multiplication process takes place inside the print statement. So if we run the code, so the loop of I prints the lines line by line, while the inner loop of j prints the elements of each line. Again, let's watch it in slow motion this time. As you see, the inner loop is always run completely before the next cycle, which takes us to the next line. Theoretically, there is no limit to the number of levels of nested loops. For example, another loop of k could be inside the j loop for specific calculations. However, there's a very important rule. A for loop variable, I or j or k, should never be changed by the other loop. For example, the value of I in the multiplication table code here must not be changed in the j loop, and vice versa. In while loops, that could be possible for specific calculations. However, it is not recommended because it makes the code difficult to follow and extremely error prone. However, the outer for loop can change the range of values in the inner loop. For example, if we make the range of the inner loop from 1 to I, so in this case, we tell the code that j will not go to 11, but it will go to the value of I from the outer loop. Let's run the code and see the effect. Exactly.